So if you feel like this course just sort of like shifted gears and like, went from 4th gear to 5th gear and it's like accelerating, there's some truth to that. We're dropping into a little bit, more intense material, and we're driving forward a little bit more quickly. But don't let that discourage you. Like, just kind of settle back in your seat and enjoy the ride. And then make sure that you practice this stuff and drill yourself, do exercises. I'm going to give you hands-on exercises also, but drill yourself and work something until you've got it. So create some structs, some user-defined types, and attach some functions to it. Create some methods, and then use those, call those. And then when you've got that, okay, cool, go on to the next one. But it's like anything, like any sport, like riding a bike, or playing basketball. It's like practice that layup, practice that layup, practice that layup. And then pretty soon you own that layup. And that's something that you have in your toolkit that you can use in the game. How do you like that analogy? All right, so now we're going to learn about interfaces. And interfaces allow us to do polymorphism. And so to create an interface, I'm going to, and the classic way to talk about this is interfaces allow us to define behavior. And that's kind of like, once you know what interfaces are, that makes sense. But until you know what interfaces are, it's kind of like, what does that mean? So interfaces allow us to define behavior, and then also allow us to do polymorphism. So let me show you what an interface is. So we're going to use the same syntax here: type, and then some identifier, and then like something else right there, like some other thing. We're going to do type human interface, right? And then we're going to define it, and we're going to say that anybody who has any type that has this method speak is also of type human. So notice just that similarity there, right? Where we do type secret agent struct, type human interface. We're creating our own type, or var x int. It's like, here is that the keyword? Where's the top of the language specification? Where's my scroll bar? There it is. I am way down here. Keywords. So we have var, we have type, right? So we have var and we have type. So we use the keyword and then some identifier, and then here we have some other type. So keyword, identifier, type. Here the keyword is type. So keyword, identifier, type. Just notice that pattern. Because some people get confused, like, oh, how do I declare a variable? Well, keyword, identifier, type. Oh, how do I create my own user-defined type? Well, keyword, identifier, type, right? And, or whatever it is, type foo int, underlying type is an int. How do I do an interface? Keyword, identifier, and then type, interface, okay? And if we go and we look at this, right, interface is a type, interface is a type. Noticing the pattern. So any other type that has the method speak is also of type human. A value can be of more than one type. A value can be of more than one type. A value can be, say it with me, of more than one type. A value can be of more than one type. So down here we have a value. And a value right here, that value is of type secret agent, right? So here's the value. It's of type secret agent, and it's been assigned to the identifier, the variable SA1. So this value is of type secret agent, but because it also has the method speak attached to it, it is also type human. So this value is type secret agent and type human. So a value can be of more than one type. A value can be of more than one type. Here, just so we're clear on values, x : equal 42, right? This value 42 is going to be of type int, right? So value is of a certain type. This value here is of type secret agent and type human. A value can be of more than one type. And so we could do things like func bar takes in a human and then does something. Okay? That's it. I called human. Pretty cool. And we'll start with that statement right there. And so now we could create a person, and we'll create another person right here. And we'll do P1 colon equal. Let's see. So we have speak, and we have speak. Yeah, we'll do P1, and this is going to be a person. And so here's our composite literal. And then we need first, and that's going to be doctor. And we need last, and we need no. So that's Dr. No. We'll mix it up. And this next James Bond movie that we're creating, or Miss Moneypenny becomes the hero, there's going to be a Dr. Yes. I don't know what that looks like. It's more positive, though. And now we'll print out Dr. Yes. P1, printing out Dr. Yes, format, run. All right, so there's Dr. Yes, cool. And we can see that these are calling speak. And then we'll create another function. And this just gets, you'll get into this as you get into the language. So I'm just introducing you to it. And now we're going to attach to type person speak, right? And we'll do the person speak. That there. I'll do that there. Cool. And so now type person has the method speak attached to it. Type secret agent has the method speak attached to it. So they both have the method speak attached to it. And any type that has the method speak is also of type human. And then bar takes a human and I called human. Bar takes a human, and you can pass a human into bar. That's what we want to show. I was passed into bar. Passed into bar. There, we call it that. And then we'll print out the H. Cool. So now each of these, we could do bar, and we can pass in SA1. We could pass in SA2, and we could pass in P1. So notice what happened. Bar is taking a secret agent, This is a value of type secret agent. This is a value of type person. So bar is taking in a secret agent and a person. And it's able to do that because both secret agent and person, both secret agent and person, are also of type human, and we've asked bar to take in type human. Right? So that's taking in type human. And that's polymorphism, many, morph, change, right? So this function can take in many different types, right? And depending upon those types, we could change what that function does if we wanted to. And polymorphism. So that's interfaces, and interfaces allow a value to be of more than one type. And both person and secret agent both have a method speak. So they are also, any value of type person or any value of type secret agent, they're also of type human. And so then we could pass around a human and ask for a human. This is really useful because if we go to the documentation and we look at like IO writer, right? And we look at TypeWriter, and I'm just looking at TypeWriter, which is a funny type. Right here, TypeWriter is an interface. And any type that has this method, right, implements the writer interface. And so we could create functionality, like if we go to godoc.org and look at net HTTP, we could look at the index here, and we could see what takes a writer. And we could see the writers that are taken. I'm just looking for... Like all these things are taking a response writer, right? And a response writer, here it takes an IO writer. The header takes an IO writer, net HTTP, here it takes an IO writer, right? So we could write things. And so writer allows you to pass anything in, and that implements the writer interface. So you could have different elements which work where if they have that method, and they could all implement that method slightly differently. So it's a big thing to wrap your head around, and this is just a start if you're just being introduced to it. But if you are familiar with it, then you're seeing how it works. So let's watch this run. Undefined S and S first. S first. Line 22. P. All right. And I was passed into bar James Bond, true. I was passed into bar Miss Moneypenny, true. I was passed into bar Dr. Yes. So that's pretty cool. And that's polymorphism. And one more thing I'll say about that, maybe two more things, is that here's my joke. An interface says, hey, baby, if you've got this method, then you're my type. Hey, baby, if you've got this method, if you have this method or these methods, then you're my type. If you have these methods, then you're my type. That's what an interface says. So if you have this method, then you are also my type. And person has that method, so person is also that type. And secret agent has that method, so secret agent is also that type. So that's what an interface says. And then we've seen conversion. So I'll show you conversion. And so just give you an example of conversion. And conversion is if we have var, let me just think this through. We'll come up here and we'll do my own type. So the keyword, the identifier, and I need something here, I don't know, hot dog. And the underlying type is an int. And then if I do var x hot dog equals 42, format.println x, format.printf, %t \n x, right? And then format.print, and then y var y int, and y is equal to int conversion around hot dog, right? And then we could do all that with y. So we have 42, we have hot dog, right? And then we have 42 and we have int, because here we did conversion. That's conversion. So now I want to show you assertion. So assertion is you're asserting something is of a certain type. And so now we could do this. And this is just FYI, kind of like a nice tour. It's showing you what's possible and giving you a look at the more intermediate to advanced material. So I can't just say H first, because this might be secret agent, or it might also be person. And so I could do H, that's fine. It'll dump everything out. That totally runs. So we're back to running. But what I could do is I could come up here and I could do a switch statement. So remember, we have switch, and then we're going to have something there. And if I just leave it blank, it'll switch on, expressions that evaluate to true or false, being the first one that's true. And then we'll have cases. I'm going to do switch H, and then I'm going to do type. This is a special type of switch statement where I could switch on type. And then I'm going to say, hey, if you're, if the case is type person, do something. If the case is type secret agent, if that's what the type is, do something. And I have some code here, which you could just kind of pause your video and you could see this, and gives you a little bit of insight into that, including the empty interface. And I'll talk about that in just one second. But again, this is just a preview deal. And so now I could say what I want it to do for each of these cases. And I could use assertion here. So I'm going to assert, and this is different than conversion. I'm asserting that this is type person, and I'm asserting that this is type secret agent. And I know that because I just did that switch. And now I could call first, right? I could call first off of that because I've said, hey, you know what? I know this is type person. We just checked it. So let's call first off of type person. So when you have an interface and you need to get back to the concrete type, the type underlying that interface, you could do it this way, format it, run it, and now you could see, and let me just change this so we could see where that is happening. Format it and run it, and you could see here, right, that one worked. I called, James, I called Miss, and I called Doctor. And so that's assertion. So conversion was down here. That's conversion. And assertion is I am asserting. And that's a little bit stronger. Converting, I'm converting that value to a different type, right? And that makes sense. I converted type hot dog. Where is it? Converted type hot dog to an int, conversion. Here I am asserting. That's kind of like a strong active word. I'm asserting that this is type person. I'm asserting that. And I checked it with this switch statement on type. So that's how you could kind of like, once you have something that's general, you could get back to the specific or the underlying concrete type. Seems like there's one more thing I was going to say about that. I don't remember what it was. I'll rewatch this video. Be like, oh yeah, that's what I wanted to say. So that's a whole lot about interfaces and polymorphism. And don't feel like you got to nail that if it's new to you. But if it's something you're familiar with, then it's good to see and good to know about. And as you program, you'll learn more about it. So let me just see if anything else I wanted to say comes back to me. I guess the last thing I'll share is just a little bit of a review. And remember what interfaces do. So interfaces allow us to interface, allows us to interface in a different way. And so a value can be of more than one type. And so an interface says, if you have these methods, then you're also my type. And remember this interface down here, type human interface, right? It's saying if you have this method speak, you are also of type human. So both person and secret agent have the method speak. So they are also of type human, and that's a common type shared between them. So when we ask for a value of type human, like we do here, right, either a person or a secret agent could be passed into that. And that allows polymorphism. So that's kind of what interfaces are. And if you have an empty interface, right, so if that was an empty interface, then every other type is going to have no methods, at least. They also have no methods. And so everything implements the type empty interface. So when you see in Go programming something asking for the empty interface, and that's the other thing I wanted to say. When you see in Go programming something asking for the empty interface, every value can be put in there. And we see that in the documentation. So if we go and we take a look at like, godoc.org, and we'll just look at the fumped package, right? And inside the fumped package, right, here, these are all asking for an unlimited number of types. Here's print line, unlimited number of values of type empty interface. Every value implements type empty interface. And so every value could be put there, or no values, 0 or more. So now you understand this thing, a variadic parameter of empty interface. You understand that. Every type has no methods. They might also have one or two methods, but in addition, they don't have any. And so they implement the empty interface, and they could be, every value is also of that type. So even an int is also of type empty interface. And so values can be of more than one type. That's a profound concept and provides a lot of power and flexibility in creating programs. So good for you for hanging out for this entire video, because the last thing I'm going to introduce you to is Bill Kennedy has this article on composition. You could just search for Bill Kennedy composition with Go, going Go programming. We've been talking about composition, and here he lays out a program which has nice interface design, right? So creating a struct, and then interface, right, and another interface, and another interface. And he shows you how you could start to build programs using interfaces. So this is a nice document, nice article to read through. And Bill Kennedy is a personal friend of mine. So I feel like, I feel really fortunate and lucky. Both Bill and Caleb Doxey, like they're friends of mine, and it's nice, I don't know, it's nice to share the good work that they're both doing in the world, helping people learn about programming and learn about this language. So they're great resources to consult with. All right, so that's a fair amount about interfaces. That's a fair amount about interfaces and polymorphism And I hope, watch this video again if it went a little bit, like the concepts are just really new to you. But I hope that gave you some good exposure to how they work.